Today, I'm going to show you an interview that I got to do with the SWE-bench team. These are 3 researchers out of Princeton that are responsible for SWE-bench, the benchmark that tests the coding ability of different LLMs, and SWE-Agent, an agentic framework that accomplishes real-world software tasks. We covered everything from the origins of SWE-bench and SWE-Agent to the future of programming and so much more. So really excited to share this with you today. Let's get into it. All right. Welcome, guys. Thank you so much for taking the time to chat with me today. We have Killian, Ophir, and Carlos from the SWE-Agent team. These 3 guys are from Princeton University. Everything that they are working on are open source projects. You can download them for free. You could play around with them. I've already done that. So definitely check it out. I'll drop all the links in the description below. So yeah, check it out. And thank you guys for contributing to the open source community. It is very appreciated. All right. So I want to actually start with kind of just a nice icebreaker question. What does your coding stack look like today? What are you using? How are you doing testing? How are you writing code? What IDE are you using? I'm curious. Killian, why don't you start?
So I recently switched to Cursor actually after Carlos did that, and I was using GitHub Copilot for a while, and obviously we all know that this is kind of magic and really makes our programming lives more enjoyable, plus or minus like an occasional bug that's caused by Copilot. But I love the fact that with Cursor I can press tab and it can complete things even somewhere else, like even if there's like a logical follow-up change at a different cursor location. That was pretty big.
Okay, so Cursor for the IDE. Do you know which LLM you're using powering Cursor?
That's Claude. Yeah.
Claude. That's exactly what I'm using.
After I switched, GitHub Copilot I think released a like rather major update. So I'm pretty sure they are like working on catching on. I don't think they're gonna stay behind for too long, but you never know.
Okay. Yeah, it's so funny. I recently discovered Cursor, which is kind of crazy. I was a GitHub Copilot user right when it came out. And yeah, Cursor blew my mind. Actually, the Crew AI founder showed it to me and how to use it. And the fact that you can Command L reference specific files and say, change this one within the context of these other, very, very useful. Ophir, what is your stack?
I don't really program much these days. The last time I wrote a substantial amount of code was when we were developing SWE-Agent. When was that? Like a year ago? More.
Like in January. February.
Oh yeah, less than a year. And I was using Visual Studio, and then at the time I was talking to a language model. I can't remember what it was. It must have been like GPT-4. Yeah, it was probably GPT-4 to help me write code. But I would just go to the website and ask it questions. Yeah, and then most of even in SWE-Agent, most of the work I was doing was just reading trajectories and then modifying the prompts. So most of the programming there was John and Carlos, and then Killian joined.
All right, then Carlos, what stack are you using right now?
Yeah, so kind of like Killian mentioned, so we've been using a lot of Cursor for IDE stuff. Of course, we're actually moving a lot of like some infrastructure to cloud computing, and so in terms of cloud stuff, there's a lot of AWS, like kind of container like batch and stuff powering some of our evals on the cloud and our like SWE-bench like automatic evaluation. So there's like a lot of kind of AWS stuff happening now too.
Okay, great. So I want to jump into SWE-Agent and SWE-bench. I've talked about both of these things in multiple videos on my channel, so I think folks mostly know what it is who are watching, but maybe you could just give a brief overview first of SWE-bench and then SWE-Agent. What are they and what inspired you to create them?
Yeah, so I can answer that. So with SWE-bench, the story with that is essentially, I think, so John and I were kind of hanging around in Princeton over the summer, and a lot of people were on internship or away, and so we were kind of just brainstorming a few ideas one afternoon. And I think the idea of SWE-bench kind of started just as we were thinking about how to use the GitHub kind of infrastructure a little bit more in depth, as opposed to just like taking code. Because a lot of people had been training on code from GitHub, but there's a lot more infrastructure on GitHub than just like repository, like just kind of hosting code. There's a lot of issues and pull request like kind of infrastructure for open source collaboration and stuff. And we were thinking about ways that we could make use of that type of thing. And so I would actually say we kind of started with that premise, and within 20 minutes it kind of became obvious like what the idea for SWE-bench was going to be. And to kind of give an explanation of what SWE-bench is on GitHub in like this open source kind of collaborative development community, you have open source software where developers can post their software in the public, and users of that software can kind of report bugs that they have with them, and it's all happening out in the open. And so that someone can submit a bug report or submit some issue to the maintainers of the repository out in the open. And the maintainers of the repository or anybody else, any kind of open source collaborator, can see that issue and maybe try to update the software, update the code to fix that bug. And at its core, that's what a lot of software development is about, is kind of iteratively improving and adding features and fixing bugs to software to make it better, more reliable, faster, and everything. And since that happens all out in the open for the open source kind of software on GitHub, what SWE-bench does is essentially try to turn this setup, turn this structure of this website into a way to like test language models on their ability to do something very similar, to essentially solve users' bugs and like fix software and fix these bugs in like real world kind of settings. And so that was kind of new. That was something that hadn't been done exactly. People in the past were kind of evaluating language models on I would say kind of very small like programming challenge type questions. So maybe in a software engineering interview, you might be given a task of like, oh, here's kind of an example problem. Can you write a function that does some kind of complicated sorting or calculates the most efficient way to do something with that problem. But that's very different from kind of real world programming settings. And because GitHub, it's very much the real world. GitHub really powers so much of like the open source software, which is super impactful today. These types of problems are like way closer to like the problems that an actual software engineer would deal with day to day. And so that's kind of what's unique about SWE-bench and how that came to be.
So are you taking... Oh, Killian, please, sorry.
Oh, it's just a story that I remember that I think Ophir told me, was that at the beginning, since language models were only ever evaluated on like those simple kind of completion tasks and we're struggling already there, it was apparently hard to get people even interested in trying to crack SWE-bench because the task was seen to be so hard that people were just kind of not motivated to even attempt this. Until basically SWE-Agent also.
Yeah, just to clarify timelines and team members. So Carlos and John led SWE-bench. So John Yang, who couldn't come, he finished his master's at Princeton, and then he was like a research assistant. And Carlos is a PhD student. And then so they started SWE-bench, and then I joined. I began my postdoc at Princeton, and so I joined that project. And then Killian joined us right as we were finishing SWE-bench. So Killian is not on the SWE-bench paper. No, he... Oh, right. Sorry.
It's actually right after when you were releasing SWE-Agent.
Yeah. Sorry. So we did all of SWE-bench, and then... So we released SWE-bench, and then this is interesting. We put it out, and nobody wanted to even look at it because it was so challenging. So when we put it out, the top accuracy was 1.96%. So we had a few like baseline systems. None of them were agents. They were all really simple, and they got 1.96%. And so people were really afraid to try and work with SWE-bench because they were like, this is too challenging, it's too hard, and nobody really wanted to bite. And right when we finished working on SWE-bench, it was obvious to me, to John and Carlos, that we wanted to work on an agent for this. It was just obvious to all of us. Like, we didn't even have to talk about it. And we were like, we want to build an agent. And we were kind of starting to work on it, and we saw how hard the task was. And I told John and Carlos that if we get more than 6% accuracy on test, I'm going to buy everybody gelato. That was like my big, we were kind of trying to estimate, like, how well do we think we're going to do? And I was like, dude, 6% is going to be so crazy. Like, I really hope we can get 6%. And we started working on it. We were all super excited about it. Meanwhile, nobody's making any submission on SWE-bench. And then this is around March, I think. We're about to release SWE-Agent, and we're getting at this point like 13% accuracy. So we like surpassed what we thought we were going to get by a lot. It was a lot of hard work. We would kind of have these ideas for new commands to give the agents, and we would try it, and it wouldn't really do much. And then we tried a different command. We tried giving it all kinds of tools. At the end, what seemed to work well was like designing an interface that was special built for the agent, an interface that was built with the agent in mind. And what we talk about in this paper is this concept called agent-computer interface design. So just like when you build an app for humans, you have a lot of like GUI designers design an interface that's built for humans. We had to design a computer interface that was built for an agent. And so, for example, if the agent wants to view a file, a simple thing you could do is just show it the entire file. But we found that really confused the agent. Agents and language models in general like inputs to be as short as possible. They get really confused the longer the inputs are. And so one of the things that we discovered is that we built this file viewer that only shows it 100 lines at a time. And if it wants, it can issue like a scroll down command to scroll down, a scroll up command to scroll up, a find command to find something in the given file. And that really improved performance. And we actually show in the paper that if you show it 100 lines at a time, it actually does better than if you show 200 or 300 lines. So all these explorations were just months and months of trial and error, of reading lots of trajectories. At one point, we were really struggling with getting the agent to edit files correctly. And we were just trying all kinds of different methods. Given a specific file and a thing you want to edit in and a block you want to edit in, how does the agent phrase that? How do we want the language model to phrase that to the system? And if you talk to anybody who's built a programming assistant or a programming agent, that's a really big issue that everybody struggles with. And we were working on it for like a month or 6 weeks, and we just couldn't really get it to work. And then one day, John just comes up with this linting idea, which was just so smart. But John integrated a linter. And so whenever the agent tries to edit, it would make these like very weird mistakes that a human would never make. It would kind of copy the same line twice, or like accidentally, instead of editing lines 110 to 115, it would edit lines 111 to 116 or whatever. It would make all these small mistakes. And John figured out that if we automatically run a linter every time after the agent makes an edit, it would catch a lot of these silly mistakes. And so that kind of just took us to the next level in terms of performance. And then we decided to launch. And then a week before we were supposed to launch, we got an email from Devin, and they were like, hey guys, we're going to launch tomorrow. And we were like, oh, cool. Somebody's making a submission to our benchmark. They were the first submission ever. We didn't think too much of it. And then the next day, it just went super viral, and everybody was talking about SWE-bench. And then we had that submission ready to go, and we put it out like a week or two later, and we obtained basically the same performance as they did, but we were much faster, than Devin, and we were also totally open source. And so Devin launching and then SWE-Agent coming right after it kind of launched this massive wave of interest in SWE-bench.
That's a great story to hear. A couple things to clarify. So SWE-bench, in simple terms, is a way that LLMs can be tested on their ability to complete real world coding tasks. Is that a good, simple understanding? Okay. SWE-Agent is your version of kind of an LLM wrapped with an agentic framework to try to get the highest score on your SWE-bench. Devin, I think probably a lot of people have heard of it, but basically they're closed source, agentic plus UI agent coder thing. I think I don't know a better way to explain what that is.
Yeah, so I can briefly
please.
just mention the differences between us and Devin and OpenHands. I think there's kind of two ways to approach. I mean, there's a bunch of ways to approach assisted programming or AI assisted programming. There's a kind of most basic method, which is like the Copilot and cursors of the world, where they just kind of show you, you're just programming and they offer like a block or a line of code, which they think could help you. That's the most basic thing you could do. And what we're doing is on the other side of that spectrum. So we want to go from just a bug report or a feature request to a full implementation without any human interaction. So we're fully autonomous. And then in the middle of that, you have tools like Devin and OpenHands, where it's like a programmer and AI, collaboration. It's not fully autonomous. It's not, but they do develop full features, but like it's with a lot of human input. And so, yeah, I think there's usefulness in all of these tools, but we're all in kind of different segments of this market.
Yeah, it's interesting how there are different approaches to this, from this is something to superpower you as a developer, all the way to a single prompt or single GitHub issue, feed it, and it's going to autonomously complete the entire task, including implementation. So it's really interesting. And actually that kind of dovetails well into what I wanted to really ask you guys about, which is the future of programming with AI. Maybe I can start with my prediction, and then I want to get your thoughts on it and hear yours. I believe over the next 5 years, we're going to see an explosion of the number of people who are contributing code or building something with code. With all of the tools from SWE-Agent to Aider to Devin, it just allows people who previously were either too intimidated to get started or just maybe didn't have the complete in-depth skills to do so. They're able to build a lot of things now. But then I think in the longer term, 10, 15 years from now, and this is maybe a controversial take, there probably, in my opinion, won't really be a need for programmers at all. Especially when you look at demos like the AI Doom demo, where there's no underlying game engine, or the AI Minecraft that just came out a couple of weeks ago. There's no underlying game engine. It is just using diffusion and a predictive model to predict the next frame. And so in that model, if we just continue that thought experiment out, they're really like, where, if the operating system is the LLM, where do applications sit, if at all, and then where do developers sit? So that's kind of my prediction of the next, short-term explosion of developers, long-term, maybe no developers. I would love to hear each of yours. Carlos, do you want to start? Like, what are your predictions for short-term, midterm, long-term?
Yeah. So I think short-term, you're kind of right. Like, you're going to see a lot more people, like these kinds of systems and tools and programming languages and tech stack that I think has previously had a fairly steep learning curve. You have to, a lot of people spend a long time, learning how to program and learning how to use. Even every tool has its own learning curve. And so I think now, especially because language models have like a really good broad like knowledge base, and then also it can help kind of any programmer jump into like any new tool pretty like way faster than before, where you had to spend a lot more time like on that learning curve. So I think you're right that like these LM kind of assistants, these AI assistants kind of, I think, really make that learning curve a lot shallow, like a lot flatter. And so people can kind of on-ramp onto new, using new products and tools and software and tech stack and everything, like a lot. And so you're right. I think that would expand for sure. In terms of longer term kind of vision, I do think that there is going to be a lot more done automatically by AI assistants. So something along the lines of SWE-Agent, where you kind of have an automatic agent just kind of, try its hand at refining a code base and fixing bugs and addressing kind of software issues that people experience. I think you definitely will have people, because it's it costs nothing. It's super cheap to like say run SWE-Agent on all your bugs, for instance. It's like a couple bucks, and I think like as these systems get even better, there will be a lot more, humans will play a lot more of a role of just kind of reviewing the kind of, maybe like kind of like QA for software, like AI software engineers. And so we might have kind of human QA tester, like QA engineers doing this type of in that role a bit more. And then a lot of the actual programming is going to be done by agents or done automatedly. And that's kind of how I think that also plays a little bit to the first point that you mentioned, where is because it's going to be so much easier for people to produce code generated, partly by AI. I think that so the kind of QA, world where most engineers are kind of just supervising at updates and improvements that these AI software engineers are generating will just be like a more professional version of that in a way.
Do you think, Carlos, before Ophir, I want to get your thoughts on this as well, but Carlos, is there a future in which the language model itself is the operating system and the end user, not a developer, just somebody who is interacting with information, gets what they need in real time, not before, where there really is no underlying code there? Or is that just too far-fetched?
That does sound like a fairly extreme kind of vision of like computing in the future. I can't imagine. I'm sure there's like very creative ways to go with that. I'm not sure if they would be the best or like the most efficient or something. Although there could be some kind of like, I think if people were to do more research on things like that, like the kind of AI doom that you mentioned, is I imagine it's, at least right now, it's a very like inefficient way to like make a video game or something. But yeah, I mean, if I think more researchers kind of working on kind of AI as like generating something that a program might traditionally do, there could be very interesting like products at the end of that. So, but I think it seems very, like an unusual kind of way to think about it, at least right now.
Yeah. Ophir, what are your thoughts? So short, mid, long run, how will AI change programming?
Actually, let's let Killian go at first, and then I'll go last because I want to hear Killian's response before.
Okay, Killian, please. Short, mid, long term. What are you thinking?
So short term, I think, so the main thing that I really like is that if you're already like a good developer and you have a fairly good overview and sense of quality in code, then all of these innovations will supercharge you. Right? Because previously, I think all of programming, there's like a certain amount of thinking and knowledge, but then there's like a lot of busy work. You just have to put down the code in writing. And this is what's holding programmers who are really good at their jobs. It's holding them back because it's just lots of time. And I think this shrinking will make programmers who are really good, who are really in their element, make them crazy productive. And I think this will really drive industry. So I think that's both short and I think that's already short time. That's already happening with Copilot. And I think mid-term, I think hard to say which way it's going to play out. On the one hand side, you could say like everyone's going to be crazy efficient, so we need less programmers, but it's also just going to lower the price of the products. So there might be, places where software engineers are not like where the software was not cheap enough to be used yet, like that actually drives up the demand for software to be written. I think there's I forgot, it's like a general principle like about if you make things more efficient, it doesn't mean that you're gonna consume less resources.
Like
because
Devin's
oftentimes,
paradox.
oh yeah, that's it exactly. So I don't know if midterm the number of programmers are really gonna decrease. But so long term and like looking more at the vision side, I think it depends on what you want to do. I think certain programs probably don't have to be written anymore. You can certainly already like do things with ChatGPT that previously you would have to write a program for. But then if you're thinking of writing very large pieces of code, first of all, like especially like more critical scenarios, you want to have guarantees of how your system is going to behave. And the larger your system is, the more important it is that every single part of it fulfills certain guarantees. And language models are not capable of being entirely predictable. That's just not what they are. So I think code will stay at the base of everything because, it gives you a certain guarantee that things are deterministic, that language models don't give you. And once we accept that, then, the job of a programmer is essentially to lay down specifications that are turned into code. But at some point, there's no difference between what you consider code and just very good specifications. Like it's just going to be like a very, very flexible, a very high level programming language that I'm gonna write. So that's one point. And the other thing is, if you really want to be cutting edge, language models are trained on all of the legacy code you have, which means they are always going to be lagging behind. Like if something new comes out, first of all, like the language model is not trained on it yet, so it's probably not even going to be aware of it. But even if it was, it does not have the capability to decide, oh, this is like a new standard, or this is like new, very elegant thing, I'm going to adopt this now. Because like there's just the overwhelming majority is kind of the industry standard. And like depending on, what your view of industry standard is, that means it's just going to be like kind of old, maybe too complicated code. And it's kind of be like you can't be an early adopter with language model generated code unless you tell it very specifically, and then you just like you have to very carefully lay out the specification, which is basically programming just again. So I think there will be programmers, maybe like what that really entails, and if they're gonna write in human or in some kind of specific programming language, I don't know. But essentially it's gonna be the same job.
Yeah, that's interesting. I hadn't really considered that the language models are essentially going to be an average of the quality of the code bases that they're ingesting right now.
Yeah.
So I guess obviously with like really good selection and pruning, you could probably get the best of the best code. Yeah. And that's probably a way to differentiate yourself as a coding specific model.
For sure.
Ophir, what are your thoughts here?
Yeah, so in the short term, there are going to be these tools like SWE-Agent where you can just request a feature in human language or describe a bug in human language. And you're just going to very quickly get a PR from an agent, and you just have to verify it. And initially, they'll only, fix 5% of bugs or whatever, but maybe in 2 or 3 years, they'll manage to fix 70 or 80% of these bugs that people find and like the relatively smaller feature requests. But right now, systems like SWE-Agent really struggle with very complex bugs and feature requests in general, but definitely for complex features. I don't think the tools like SWE-Agent right now can do a good job. And so just getting to the point where we can specify something in human language and get a good PR for the majority of bug and feature requests. That's going to take like 3 or 4 years, I think. I would be surprised if it would happen before that. So programmers are definitely here to stay for 3 or 4 years at least. And then after that, it's really hard to predict what will happen. But I do think that we'll just see programmers become much more effective and productive rather than programmers disappearing altogether, because I still think you'll need humans to actually write the specification for what needs to be done and then go over the outputs of these models. And then in 10 years, it's really hard to predict what will happen. But I think that computers are going to become much more useful, and normal people like non-programmers will have the same power that programmers have right now. But if you're a totally non-technical person and you're doing your taxes in Excel or something and you don't know how to program, but you're like, gosh, I wish I had a button that did X, I'm pretty sure that in 8 years or whatever, you'll just be able to talk to your computer and say, hey, could you make me a button that does X? And then it just appears and it's right there and it works. And so I'm really excited about this future in which there's no such thing as being non-technical. Like everybody's going to be technical because you're basically going to be able to talk in human language and just get these technical features and buttons in your software.
So also, I think no code as a thing, that word was around before language models took off, and what people thought is like, oh, you have like these graphical interfaces and you have like a bunch of boxes and you connect them in various ways. I don't think that really took off, and I think for some of the reasons that we are also going to see with language models, it's hard to control this. It's hard to track changes. It's hard to have like multiple users work on the same thing. So I think there's still going to be like a very like sharp distinction between casual users who just want to get something work as like a one or few time thing, and like professional software that has to be reliable. And I'm not sure, if like this magic, like I just wish something and talk to the machine will replace those.
So it sounds like none of you guys think that there's some future in which the language model just gives you what you need. There's no underlying engine powering it other than the language model itself.
No, for basic things, I do think it'll be able to do it. Just for the more complex things, I think we all agree that programmers are here to stay for a while. I don't know if they're going to be here forever, but we all see the faults in language models and why we would need like a human supervising everything.
Yeah, absolutely.
So, like,
and I think
if you have an engineer, you still have to if you want to kick off a product, you have to spend many hours explaining to your engineer exactly what that kind of product is going to be like, and like all of these explanations and like designing really what you want to build. At some point, that's not much easier than like making it happen. Like I guess like you still need to explain exactly what you want to have. Nobody's going to read your mind and just that humans can't do that either. So I don't think language models will be able to read your mind and see like, oh, you just say, I want like a button, and they make you exactly the button you wish for.
Right. And it's interesting because, just a few years ago, had you asked me, what is the most important skill you want to teach your son or your daughter? I would have said, coding. That was definitely the most valuable skill set I ever picked up. Then when ChatGPT came out and I started to see that the profession of software engineering was changing pretty rapidly, and potentially the software engineer was becoming more of a commodity, I would have thought, okay, maybe not. But there is still a lot of value in being able to have systems thinking, being able to describe your ideas in detail, being able to think of edge cases. So I think like you're right. There's this area in which it still takes a lot of just raw thinking power to think through all of the different things that could happen with an idea and being able to explain that really well, whether that is in code or natural language. Either way, you have to take what's in your head and think through it expose the loop, the potential holes in it, and then describe it again well enough for a language model to build. So I want to kind of continue on this conversation. Python is certainly the language of artificial intelligence. I luckily really enjoy writing in Python. It reminds me of Ruby in a lot of ways. Do you think coding languages are going to change, and how are they going to change given AI is going to be writing a lot of it? And maybe it's a collaboration for the foreseeable future between AI and a human programmer. How is there a necessity for the actual coding languages to change, to evolve, and what does that look like?
I think Carlos or Killian should answer it, but you can talk about our experience from multimodal and what we saw about JavaScript versus Python. I think that could be interesting.
I would love to hear that. Yeah.
Yeah.
Yeah, that's a great question. That's actually a very good question. Yeah, I think like Python's nice because it's very well suited to like the kind of us human aesthetic preferences, and it's not necessarily. But it's not necessarily like those preferences or what's kind of suitable for humans to kind of parse and think about and like visualize are not necessarily the same as like a language model. So I could maybe imagine like a programming language that is like very efficient for language models to like use. For instance, I'm totally speculating, but yeah, probably more like statically typed things would be more efficient for language models, like as opposed to Python. I would guess probably like I mean I have no idea, but I'm sure researchers could like figure out, you know, there might very well be things like some kind of language paradigm and structure that would be more efficient than Python, and maybe language models are more suited to like generating that type of thing. At least in the short run, probably the biggest like issue is partly that just like there's so much training code, like training data for Python, and language models are pretty good at Python right now just because there's a lot of it. Similarly with JavaScript, I think in general like performance of language models correlates to some degree with the popularity of those languages for sure. And so there's still going to be an effect like that. Whether there could be something like higher level, like a language model paradigm, like programming language or something, that I think that's something that's kind of cool. I don't know, maybe something like that could also exist where like a language model is kind of core to the, you know, compilation of that language or something. But yeah, I don't know. I think that's all very like still kind of speculative.
Yeah,
I'm
and
not sure
like
what it would look like.
maybe even a little science fiction-y. The reason coding languages look like what they look like, you know, basically akin to natural language as much as possible, is because humans need to read them.
Yeah.
And maybe there is a programming language that would suit a language model that doesn't look like anything that we've seen before, and maybe is not even human readable. Now, I know the counterpoint to that is, well, all of the training data is natural language and coding languages we're familiar with, but maybe it won't always be that way. Killian, what are your thoughts on these topics?
Yeah, I think it's a really cool question. So one thing like that Carlos already mentioned, like when he said like static typing and something like that, I think, again, thinking about guarantees. So I think for humans, there's like a trade-off, and you want to get the job done. And so you want to have a lot of flexibility and like a certain kind of high level language. And Python is very, very flexible. You can do whatever you want. There's very little guarantees, like compared to like a statically typed language. So I could think of maybe like the trend going kind of backwards to something that's a little bit more static, might be like a little bit more, you know, characters that you have to type. But like typing speed is no longer going to be an issue because you're going to have like super fancy autocomplete. So maybe it's like like moving more towards something that has more guarantees built in, or maybe in its extreme, I mean, there's specific languages for testing things, for writing tests. I think Cucumber or something like that exists. Maybe it's gonna be like a total paradigm shift where our work, switches a little bit more to writing lots of kind of statements about what a function should do. And then, like the small part that's mostly handled by the language model is like going to be like, okay, let's actually make this happen. But like that kind of our priorities as programmers switches to writing the checks and like like a language really optimized for that. And like, like the body of actually implementing this. That's kind of the easy part then.
True adherence to test-driven development.
Yeah, I mean, I think test-driven development it's not really a thing in some ways, because like oftentimes when you write something, you learn about how like what the actual problems is. So I think even in industry, test-driven development, I think is mostly a pipe dream, because like if you try to write the tests before you know how you're going, like I think it's going to work with integration tests. It's not going to work with unit tests, because unit tests depend on implementation. It's very hard to figure out the implementation before you're writing it. So I don't know, but like something along those lines of like having like a more fluid mix between like guarantees and maybe like we don't have to think so much about like number of characters. Maybe it's actually going to give like more. Maybe it's gonna give rise to languages that are more complex than Python again.
Ophir, what are your thoughts?
Yeah, I mean it's a very deep question that we don't know the answer to, but I've been doing language modeling research for 9 years, and the three most important things when building a language model are the training data, the amount of GPUs, and the amount of training time. That's it. So even the architecture itself of the language model doesn't matter that much. Training data and compute, basically. And so just because of the fact that if we make up a new language, we're not going to have a lot of training data for it, just because of that, I think it'll be very hard to kind of have like an AI programming language catch on, because you're just not going to have enough training data. If we wanted to pose like a hypothetical question, like, if we had, infinite training data in every language, would a different language be more suited for language models? I don't know the answer to that, but I don't think it would matter that much. I think there are tougher problems we need to solve first before that becomes an issue.
And one thing I could see is, I mean, transpilation being like a bigger thing. Like, like there's already like some paired languages, like I think TypeScript compiles to JavaScript actually, and then like the JavaScript is actually what's on. I don't know if that's true, but like, so maybe there's like, you have something new that's going to compile into this other language, or like where like there's like a little bit of split, like it's kind of two languages that are in some way connected, and like one of them is like one where you have like a lot of training material, and the other one is something like that. I think that would be like a really interesting direction to look into.
Yeah, absolutely. It's such an interesting time to be even just like talking about software engineering and AI. Like I'm kind of, that's all I do is just talk about it. I do some coding just personally because it's enjoyable to me, and I want to use these tools. But it must be so cool to kind of be inventing it as you guys are going along. And I want to transition to talking about the future of SWE-Agent and SWE-bench. What do you guys have coming? What are you most excited about? I don't know. Ophir, do you want to go first and talk about like what could people expect? What cool features do you have coming out soon?
Yeah, so we have two big new things coming out, and I'll let Killian and Carlos go into more details. But basically, we have a huge refactor of SWE-Agent. So we're going to launch SWE-Agent 1.0 very soon. Probably by the time this video comes out, it'll be out. And so we're making SWE-Agent much easier to run, both on your own device and in the cloud. And we refactored like the whole code base, so it's much easier to extend it. So if you have your ideas for how you want to make SWE-Agent better, you can do that pretty easily. So I'll let Killian talk about that because he's leading that. And then we've had SWE-bench and it's been out for a year. And we recently put out a new iteration, a whole new SWE-bench. It's called SWE-bench multimodal. So the paper describing that benchmark has been out for a month or two, but we have yet to release the evaluation infrastructure for that. So it was impossible to make a submission on SWE-bench multimodal. But we're now releasing the software for that. So again, that's coming really soon. It might be out by the time this comes out. So SWE-bench multimodal is just like SWE-bench, but instead of just solving GitHub issues, you have to solve GitHub issues that involve some kind of visual component. So it's like UI elements in JavaScript that aren't displaying correctly, or maps that aren't rendering correctly, or plots, diagrams, art. It's all in JavaScript. It's very, very tough. And I'll let Carlos get into more detail on that because he's leading that.
Sure, maybe start on like the whole
Yeah,
refactor
Killian,
idea.
please jump right in.
So I think kind of the brand of SWE-Agent is always that we want to be a very easy to understand, very straightforward project that people can take and adapt and hack very easily. And I think that's already us. But with the new refactor, we're going to go even more in that direction. Like the code base has shrunk. It's much more compact. It's much easier to read, but it's also a lot more powerful. Like you can now, previously you were running a lot of things overnight on SWE-bench Lite on like 300 instances. Now you're going to be able very easily with not much hardware to just run 300 SWE-agents in parallel. Just like that, just basically with a single command line flag. So things that would have previously taken like a night to evaluate, you can now realistically get back within an hour and only limited by the rate limit of your language model. So that's super, super exciting. It's going to be more stable soon, more stable too than the current implementation. And this is basically powered by a new module that we wrote, a new package called SWE-Rex for remote execution. And that's basically going to have kind of a lot of the core things of when we have the language model write and evaluate code, we need to have an environment set up where the language model tries to solve this issue. Like if you want to solve a GitHub issue, you need that GitHub repository to even start, and you need to have like everything installed in order to run code from that repository. And then you need to keep that running. And getting that done in a very stable fashion was always challenging. And this is now what SWE-Rex does, and it can do it either locally in a Docker image, but it can also just with a single command line flag say like, hey, I want to run this on Modal or on AWS Fargate or something like that. And it's just gonna do that. And this package will be entirely separate from SWE-Agent. So even if you don't want to use SWE-Agent, but you're developing an agent or basically any thing that runs code and should do so in a sandbox fashion, you're going to be able to use SWE-Rex and build with that. And you will have like the guarantee that it's just going to run because it's going to be well tested. And you can just throw out like a whole chunk of code that was probably really annoying you. And this is also what we did with SWE-Agent. We managed to separate out the most annoying parts into SWE-Rex. And it made the whole code more stable, more parallelizable, and easier to read and modify for researchers or any user.
Awesome. And by the way, I'll drop all of the links for SWE-bench, SWE-Agent, and the home pages for these projects down in the description. Carlos, please.
Yeah. So kind of essentially with the release of like SWE-Agent, the refactor of SWE-Agent, and this remote execution package that is kind of powering the backend for SWE-Agent. So that's like that. It kind of like Killian mentioned. So SWE-Agent's going to kind of become two parts where you have the remote execution backend, and then SWE-Agent's going to be like a front end where you configure your agent, configure your tools, configure your image. Do I want a browser? Do I want a display? Do I want like what kind of components are going to go into the front end side? And then SWE-Rex does all of the back end. Together with that kind of release, we're also going to be releasing code to essentially make it easier to evaluate your SWE-Agent or to evaluate in reality any agent on the cloud as well. So essentially. So right now, the kind of SWE-bench package uses a lot of local computation with Docker locally, and we're essentially going to be kind of extracting a lot of that logic and setting up endpoints, an API on the cloud, so people can essentially just like submit their predictions and submit their they can evaluate their agents using our API that can it takes a lot of computation off of the user. Running those Docker evaluation containers is like pretty big. It's just like a lot of computation. It requires fairly hefty computers, or you kind of have to go a bit slower. And so for the average user, where this probably takes several hours to evaluate your agent, that is like evaluating the predictions that it's making. That's going to come down to a couple minutes. And so you can essentially just like submit your predictions to the API. The API is going to do everything on the cloud, everything in parallel, way faster. So nothing happens locally. And then you're going to get the results back, and you can see how your agent performed like against those unit tests in SWE-bench.
Awesome.
Wait, Carlos, can you say a word about SWE-bench multimodal?
Yes. So we're when we release this, it's going to be primarily focused on SWE-bench multimodal, where we'll have free evaluation. So we'll see how long. Well, hopefully we can do that for a long time. I don't know how much demand we're going to get for it exactly, but at least right now we have some support from AWS to kind of offer this API for free, and people can submit their predictions, and that we'll be able to to get some feedback, get results on SWE-bench multimodal for free.
Yeah, so what that means is up until now, people evaluated on SWE-bench locally, and then they would just send us their result. But from now on, we're going to have these SWE-bench multimodal challenges. We'll give you the challenge. You have to use your agent to kind of program a solution. You send that over to us, and then we do evaluation on our servers, which is fast. And it also is going to reduce people's ability to kind of intentionally or accidentally cheat on these submissions. And then we'll have all the scoring done server side, and we will publish the results publicly for everybody on SWEbench.com, as we've always done. So we're excited about all these things.
Very cool. Once again, I'm going to drop all of the links to everything we've talked about today in the description below. Killian, Ophir, Carlos, thank you so much for spending the time and chatting with me. And a special, again, thank you for your contributions to open source. It personally very meaningful, and it's really cool stuff you're building. So I do very much appreciate it. Thank you guys for your time.
Thank you, Matthew. Thank you so much.
Yeah, thanks.
All right.
For having us.
See you later.